Okay, hello everybody. So if you are looking for Romangi's talk, you're not in the good room. It's a fifth room, just a door next. But you can watch his talk on Party, so please stay. Anybody in this room not speaking French? Oh, okay, so I will try to do it in English. Sorry for my poor accent. So we will talk about cloud, especially about platform as a service. And I will try to introduce all the architecture pattern and all the constraints that such a platform has. So first, I would like to know who of you already use the platform as a service. For example, who deployed an application on Cloud Foundry? Okay, a few of you. On OpenShift? Yeah. Google App Engine? Yeah, a little more. And the best of all platform as a service, CloudBees? Yeah, 19% of attendees. Okay. I will introduce myself. I'm working at CloudBees. That's a completely distributed company. So I'm teleworking. I'm a support engineer. So I used to wake up early because customer had some emergency. But teleworking is really cool. I'm also a Maven contributor and Jenkins committer. So I wrote a book on Maven. Please, sorry, it's in French. But you can buy it, so I will earn €1 and few. I'm a JUG leader in Rennes City, France. I'm organizing a conference that's called the BreizhJUG. But Stefan told me that I can't do such an advertisement for my conference, so I need to do something else to promote Devoxx. So yes, I'm born to be a geek. So let's be serious. To be honest, this talk is not strictly mine. I did a mashup from one talk about my colleague Michael Neal, and another one from Eric Bottard, and I did my own stuff. I'm not working at Oracle, but I have a disclaimer. I'm an engineer, so I won't tell you that cloud is about unicorns and things like that. I hope you won't be afraid by everything I will tell during this talk, but that's just the reality of engineering on the cloud. You probably all know the cloud pyramid. You can see it everywhere on the web. I don't really like this way to introduce cloud. I use to reverse the pyramid, because what I'm interested in is the size of each actor, and especially if you consider the infrastructure, the service layer, there is really few large-scale, world-scale vendors. Typically, we have Amazon, probably Google, and Microsoft, Apple, whatever, that are embracing the infrastructure problem at such a big level that they really can be very efficient. On top of it, you will find platform as a service. You probably will get a dozen of them that may be specialized in some ecosystems. And the next layer is your application or the software as a service. That's probably it's an exponential pyramid because there is really billions of them that you can deploy on such a platform. If you want to already leave this talk, because my accent is really so poor, just remind this slide. If you develop an application in the cloud and you want to come back on premises, at least to test your application on your local computer, it's always something easy. The main issue is to take your existing application and to make it work on the cloud. And in many cases, there is something very complex you have to do. It's called refactoring. I hope you have some test harness that will help. When you start a new application, an easy way to embrace the cloud is to start with the cloud. That's what the Devoxx team did with the new Devoxx BE seat. Probably you have seen the new website. I think it's pretty cool. It's fully developed in AngularJS with a Node and JAX-RS backend. So they started developing on CloudBees. So quickly hit the constraint of the platform, understand the issues, and were able to adapt. So that's pretty a smooth experience. But you don't always start a project from scratch. And so you probably don't all run Angular and Node.js and full stateless framework. You just have your classic application, not strictly a hype framework. And most of those applications have been designed with a single server model in mind. And then switching to the cloud introduced some issues. Last year, the Devoxx team migrated the registration, call for paper, and a few other applications to CloudBees. And they got some issues because those applications are using Wicket, Spring Framework, MySQL. So, okay, that's not COBOL. But that's something classic that really hasn't been designed with cloud in DNA. And considering a conference website, it's typically something that fit well in the cloud. You will have traffic 2 months a year, high traffic when the conference is near to be sold out, and for all the rest of the year, there's really a low traffic. You can mostly stop the servers. So they were self-hosted and moved to CloudBees and have to adapt to the cloud. That's the subject of the talk. We are talking about 99% of applications that you are developing and that you consider to move to the cloud, and you want to know how to start this process and what to take care of. The first point is what the cloud promise is elasticity, to scale. With the success of your startup, because you're on the cloud, the traffic and the resources will adapt and scale with your business. That's a promise, but what you have to know is it's about scaling horizontally, what's called scale out. You still can scale up. You start with small computer. So, yeah, sorry. So you can, if you use, we use Amazon terminology, you can start with a small server, M1 small, and then switch to a bigger one. It's just about calling a few APIs to get a new Amazon image. And then you can grow this way up to some double extra large instance. And the main question is, what's the next step? And in many cases, this happens because your business is really growing. So it's not time to re-implement everything in your architecture. So it's a little too late. And the other point is that it's not optimal because your resources on such a big server are never at 100% used. You have the day and night switch or holidays or whatever. And so you kind of switch from larger to smaller instance every time. Another point, if you look what's an extra large instance on Amazon, it's a 64 bits server with some reasonable memory. You have something that's like a 2 gigabyte CPU with a big disk. You can consider it's not exactly this one. If my boss is looking at this talk, I would like to have a new one. But this is something you probably have on your desk. So don't consider the cloud server as huge mainframe. That's about small computers, relatively small computers. Scaling out is what we used to call clustering. The main difference is that you will always adapt to the actual load. Many providers talk about auto-scaling. That means that your traffic will be monitored and the number of instances will evolve to adapt to the actual load. And the main benefit for you is that you will only pay for the actual use of resources. So for sure, if you have a bug in your application with some memory leak or whatever, and your resource consumption grows because you have an infinite loop or something like that, you will have more and more and more servers. You still need to monitor. But the cloud will be able to adapt to your application and embrace your traffic augmentation. What's happened on a platform as a service? is that a server is sliced into smaller, what we call cells at CloudBees. There's multiple noun for that, to create multi-tenant application hosting. So there's some virtualization to happen. And thanks to this, we can sell you a small server. You can select to have twice or fourth the minimal size. And we can switch application between to adapt the actual resource consumption to have a better handling on the physical resources on the road. So it's about multi-tenancy. So there is many ways to implement multi-tenancy. One of them is that hardware, some way, levels. That's what infrastructure as a service do. So you have an API, you ask for a server, you have it in a few seconds. You can also do it at an OS level. That was you have with hypervisors when you start up virtual machines. Something really interesting that has a high buzz today is OS level virtualization, especially about Docker. This already existed. It's strictly based on cgroup and LXC, but that was very technical bits to implement. With Docker, it's become really easy to do. And the next level is to consider your middleware. For example, if you want to share a MySQL database with multiple tenants, an easy way is to just create a schema for every tenant with correct permissions to isolate them. It's, the database itself is designed for this purpose. If you look at the JVM, there is some promise, you probably don't see it, but the last image is a slide from, I think it's Mark Reynolds did a talk 2 years ago or last year about Java 8 and Java 9 feature. And there is one point that's come for each new version of Java, it's about multi-tenancy. How could the JVM share basic structure between tenants? And it's really non-trivial. The next point, so the B has switched a little, but the next point is to be stateless. Everybody tell you stateless architecture is perfect, be RESTful, and so on. I would tell be stateless if you can. The promise of RESTful is horizontal scaling. You double your traffic, you just double your resources, and you will have the same response time. And you can loop with this principle as much as possible. That works if you are developing a hello world application. But for real world applications, you have a conversation between the browser, the user, and the application. You have many requests that have a context to exchange. And there is a need to manage a state. And when you talk about state, you quickly talk about cache, because you want to avoid this state, but you want to still be performant, so you introduce cache, so you introduce complexity, you introduce need for those caches to be distributed, and so on. It's not such a simple thing. A typical sample is, so Gray is a grid framework, that's just a sample, is to really be careful with the framework you are using. As I said earlier, most of the framework, even those that we use today, aren't designed with cloud in DNA. So if you take Graze and you want to introduce security in your application, that makes sense, you will just enable the security plugin. But the security plugin is using Spring Security, and this one, by default, relies on HTTP session. So your state is back on your server. And for sure, running on localhost, you don't see anything. That will only happen in production. Or if you have some reasonable testing before, you can discover it. This is just about 3 lines of configuration to switch this default behavior off. But that's not just the default. And the main issue with framework is that you have so much abstraction that you don't know exactly what's happening in the hood. And if you don't take care of this, you can have issues migrating to the cloud. And anyway, can you really be stateless? Okay, if you have a REST service that you call and reply, hello world, it's easy. If you want to exchange data and manage a context, you can do it the way Play Framework does. It's about using the cookies that are designed for this purpose. One issue with that is to say every request you do to your server will have this cookie. So running on your local area network is not an issue, but when you are in the cloud, you will introduce network latencies, so that can be an impact. You have to really take care of the size of those cookies. Another approach is to be really strictly RESTful, but then you have to somewhere have a central service that will have to address requesting every time the same IDs for each request to retrieve the base data of your conversation. So you're creating both a single point of failure and scalability issues. That's a point where NoSQL, for example, can be some sort of solution. And the last option is to say, okay, my framework uses HTTP session, I like HTTP session, I want to use HTTP session. That's, if you look at the Java EE specification, they are explicitly telling that container, the Java EE container, can distribute the HTTP session on a cluster. So they don't specify how it does, but they say it's something that the container can provide. A simple way to address this state issue is to use sticky session. That means that a user will always be served by the same server. The drawback is if this server is shut down for whatever reason, the user will lose this session. That really depends on your business. If you are just having a funny service for your fellows, comrades, no problem with that. You have few users will lose the session. If you are Amazon and you really don't want to any customer to lose in session, you probably will invest in engineering to avoid that. You can ask your platform, as I say, to manage this, following the Java EE principle to distribute around the cluster. This is something we do at CloudBees. We are using Memcache for the purpose. If you enable this feature, you just will get all your servers to share the same session storage. But then, you start thinking about login. I'm using a CloudBees specific feature. That's exactly the same issue you can have on Google App Engine. There is a lot of very interesting services integrated with the platform, but you know that it will be really hard to get on to use another provider for your application. It may even be difficult to run your application locally for some simple case. A good way to avoid this is to only rely on standards. What I call Java EE is the good parts. So there are not just good parts in Java EE. There is many classic API you can use, and many frameworks use them. And if you only rely on those ones, you should be portable. It's not always so simple. A typical sample is about the way to configure your application. Java EE tell you, okay, just edit web.xml descriptor and so on, and repackage your WAR archive before you deploy. Most of the modern framework just can be configured using system properties. That's something you will find on every provider. That's something it's easy to implement on your own desktop. You can also use environment variable if you're not in the Java world. And if you really want to use some specific services from your provider, just encapsulate in isolated classes. When I talk about standards, don't consider just approved official standard. As a developer, what we call a runtime is the minimal startup we want to have to develop an application. As a Java developer running Spring application, I just want a servlet container. I don't really care exactly what implementation it is, what exact version it is, but I want 3.0 version for servlet container. PHP developer, for example, wants a Linux, Apache, MySQL, PHP stack. Same for Node and Ruby guys. That I don't know anybody that is creating his own JVM with customization, compile it and run it on production. Maybe we should. It could be really interesting to experiment with that. But we use just to download the official JVM, install it on servers. That's a way that the platform as a service is really different from an infrastructure as a service. You ask the platform to provide you the minimal level of runtime and maybe provide additional services. But you're on the cloud, so you have latencies. For example, I'm working from France in Rennes city, and when I access servers in the US, I have 125 milliseconds latency. And my colleague Michael Neal, on the picture, you can see it's not really happy. He's living in Australia, so I don't have exactly the latency measurements, but I know that it can wait seconds to have a web page sometimes. That's something you probably already know, because there is lots of talks about the good way to develop web application, to use the Chrome DevTools, PySpeed, Yahoo Slow, and so on, tooling to measure your application, to have tips to improve. That's about minifying and grouping, CSS, and so on. This is my blog. I just tested with Google PageSpeed, so it's a blogger blog, so it's hosted by Google, and I have a grade C, so it's just really a poor performance. I think there is 80 requests just to display the welcome page, so it's slow. It's really slow. So if someone is working at Blogger here, no? Yeah. Something easy to improve this is to use HTTP cache headers. As servlet-based development, we used to disable it, so we ensure that the user always has the latest version of each resource. We want the new deployed application that has updated some JavaScript code not to be cached, so that user always has the latest version of the JavaScript code. But if you consider a cloud deployment, it's really stupid. You want the cache to happen. A very simple solution is to tell every static resource will have a unique path that will involve every time I deploy an application. An easy way is just to add a hash and some SHA-1 version or whatever, so that every new deployment will use a distinct URL. And the next step is just to use a content delivery network. That means that all your static resources will just be distributed around the world, and every user will just pick up the one that is next, geographically speaking, to his computer. So that's more about the performance aspect. But then you will hit some lower level issues. The file system. So I have a technical secret that I will tell you. Platform as a service provider are using a very specific file system. It's a Schrödinger file system. You think your file is there, but it's not. But maybe it is. What's happened is simply that when you first upload a file, for example, your application is on some slice on the server pool, and maybe after some redeployment, or maybe it could happen just on the next request, you will be served on another node. And the file system isn't distributed, it's even not persistent. Amazon call it ephemeral file system. So you have terabytes of hard disk, but you can't rely on it. It's really interesting. That's something we had with the Devoxx application last year. I know that would be an issue because on the call for paper, speaker were able to upload the PowerPoint. And looking at the source code, there was a dozen of Java EO file imports. So hopefully, most of them were DIT code. So that's an opportunity to do some cleanup. And the few remaining ones were just replaced by an upload to Amazon S3, so persistent bucket, and keeping a local copy in ephemeral file system just for quick access. So if you use this pattern to say, okay, I have to persist files, so I will send them to S3, to whatever, or it can be also a database blob, and just keep a copy for efficiency. Be careful, but in such circumstances, you have to manage some immutability, because you are using a cache as an on-file system. Comparable issue is about singletons. On the cloud, singletons are not singletons anymore. I'm not talking about the Spring singletons. We used to have singleton everywhere with Spring, but that's not an issue if we have 2 or 3 instances of what Spring calls a singleton. I'm talking about singletons that really have to be unique. Very typical samples is to schedule jobs using Quartz framework. I had a customer that had his application distributed on 5 nodes and had a nightly batch to process billing. And surprisingly, his customers were billed 5 times for the same service because all nodes were just starting the batch process. Hopefully, we are back to the framework issue, but hopefully Quartz has a very simple way to address this, that the scheduling is not managed in memory. You can ask it to use a database for this purpose. So for nightly batch, it's okay. If you have something that you want to trigger every minute, you can create some constraints, some bottleneck on database. And after a few investigations, this customer switched to another solution. He just used a dedicated cron service called Jenkins. Maybe you know about Jenkins, continuous integration server. But you can use Jenkins for whatever you want, just to orchestrate execution. So they refactor the application so that the batch is triggered by a URL call on the application. And the execution is triggered by Jenkins. And then Jenkins is polling the result and so on, and can reschedule if something wrong happened and so on. And the main benefit they had is that with this change, they were able to test the batch, because they used to prepare a test on a staging environment and then wait for midnight so that the batch starts. Yeah, that's funny, but that's really happened. and diagnose on the next day. So at this time, you're still in the room, so maybe it's not so simple, but do you really think it's a good time to migrate to the cloud? You are not as afraid as I expected. Okay, I think what you need is good tooling. It's always about tooling. And a good mind as well. What the cloud lets you do is to do software, service-oriented architecture, but I'm not talking about WS, whatever you want. I'm talking about the right way to do service-distributed architecture. Some called about microservices, with a small application focused on a subset of your business, on your data model or whatever, that you can implement in various languages. It can make sense. It's about polyglots. And you will probably not scale the same way everywhere. For example, your front end, you want it to be very efficient. You want customer to have a smooth experience. So you will distribute, have always enough resources, so your web application is really quick. Your user management can be another application. It's really focused on security and can probably be used by other applications. Your backend can be implemented in some functional language, for example. Your batch maybe will require some higher CPU box, but could be shut down and only run during the batch processing. So you really can choose different patterns depending on the smallest view of your application. For the same reason, you will be tempted to consume service. Don't try to reinvent the wheel every time. Especially the other service ecosystem is really huge. There is a large buzz about infrastructure as code, and you can find Puppet recipes for everything. But the other service world is something else. It's not about how simple it is to install release. It's how to use it without having to worry who is maintaining, who is monitoring, who is providing support. I know it because I'm a support engineer. That's really the point. You just want the service. Maybe in 2 years, when your startup will be a very successful one, you will want to implement it by yourself. But probably at this time you will have money, so it will make sense. But today you just want to be quick. It's about time to market. So you will just integrate services together. And on this topic, Amazon Web Service is really the place to be. Most of the other service providers are hosted on Amazon. Google has its own ecosystem, self-managed, that is already large. But for example, if you look at Heroku in the middle, they have a huge list of services. We have a few of them on CloudBees as well. Amazon is announcing new services mostly every week. And when I do this talk, I have many people that come later and tell me, oh, my company is considering creating a private cloud. So let's talk a bit about private cloud. Private cloud makes sense if you have such a data center in mind. This one is from Google. You've probably already seen this picture. If you really have something like that to implement, I think, yes, you can start considering private cloud because you will have a dedicated engineering team that will probably have some interesting challenge and will be very efficient at this job. But if you just have, let's say, 100 servers to manage, you will just lose your time. You already have engineers, ops to manage this, and you will ask them to learn everything about OpenStack to be run and managed on top of the existing infrastructure. You will just add software to software to software. We used to say at CloudBees that it's platform as a service as a software. You just have another software to manage, and a complex one. So we consider that private cloud is a nonsense. So for example, you produce your own electricity. You just plug. That's all. You don't really care who is actually creating it and where it comes from. You just want some watts to come to the plug. And the main reason for private cloud is about security and privacy and so on. And this is really not a technical issue. Amazon is providing, for example, virtual private cloud that lets you privatize a subset of Amazon infrastructure for your own needs with encryption and so on. So it's really not a technical issue. And when we start to discuss, it's always a question of policy. The main question is, what will your IT team do if you do to the cloud? You don't need them anymore. From an enterprise point of view, it's difficult to address. Probably you already heard about design for failure, because some say on the cloud it's not a question of if it may fail, because it will fail. Yes, it will. But yes, your own hardware also will fail. The main issue is a cloud provider, for whatever service you consider, have a status page to explain what's happening, the possible outage. So it's visible, so everybody knows, and so it makes lots of noise. For example, when GitHub has some DDoS attack, then on Twitter everybody is saying, GitHub is down, you can't use Git anymore. But especially you should use Git, because it's not an issue. You have your own repository. But something you have to address is to be too much tied to those external resources. That's something that happened to the Devoxx team just before Devoxx UK last year. That was on April 1st. There was an issue with SendGrid. SendGrid is a service to send emails. And the registration process was strictly sequential. You enter your name and so on, credit card, and you hit register, and it sends you an email for confirmation. But the service was down, so Threads just started to wait for the email to be emitted, and the application was down. Typically, that's something you can do asynchronously, and just come back later to process the remaining mails. That's a question of architecture, software architecture that also makes sense for performance and many other topics. And anyway, cloud is safer. Some unofficial metrics. Last year, Amazon had 2 major outages that we suffered at CloudBees. We weren't able to start new servers. So the existing servers were still running, but we weren't able to start new ones. So the service was more or less down for 20 minutes first time and 10 the second one. So in terms of uptime, it's a 4.9. It's not too bad. The main issue is as I told you earlier, when GitHub is down or when Amazon has an outage, then Netflix is down and everybody is down, and so it's incredibly visible. When your own hardware has some issue, it used to happen on Friday, then probably it will be up on Monday morning, but it's not visible. Monday morning is the best case. And for the same reason, cloud providers all have disaster recovery policies. So it's simple for CloudBees, where it's documented in Wiki. Everything is stored on Maven history. We do snapshots and so on. And you can for sure have your own backup system on top of it. And if you really want to be a high availability, you can distribute on Amazon availability zone. You can even distribute on different regions. That means that your application will share data between Ireland and Virginia and maybe Asia Pacific regions. But then you have to synchronize with network latency. There is no silver bullet solution. You have to rethink your architecture. You have to consider, okay, maybe I can have few seconds synchronization delay between instances in different regions. It's not so bad. It's really a case-by-case consideration. I was telling you that your IT guys don't have job anymore in the cloud. That's completely false. I think there is no hope here because I didn't heard everybody to notice this. What you need is a new generation of ops, because what a platform as a service do is to manage your runtime, your application container, but not your application. I said earlier, if you are doing an infinite loop in your code, it's your code. Maybe you want to do an infinite loop. It's not really my problem. So you have to instrument your application to monitor what's happening. There is a lot of software as a service that really focus on this specific use case. New Relic is a famous one. AppDynamics lets you connect something that's really looking like a profiler to your application. Papertrace is a log gathering system that lets you consolidate logs from various nodes. You can use hosted graphic to publish metrics and compute data for your technical or even business dashboard. So yes, this is a new generation of tools you have to learn. It's not anymore to read a 10 megabytes logs searching for a bug. It's another level of tooling. That's something I like. I consider that cloud is really fits very well in the DevOps movement. The DevOps spirit is to consider that both developer and operationals are in the same team and have the same goal, is to get this application running. And what we provide is the same platform for everybody. For example, in traditional development, you have your own development environment on your laptop. You have some integration, staging, or whatever environment to mimic the production, and there is the production. And probably no developer can really access the production. When you are in the cloud, you can replicate the exact same environment just for your own testing. You can replicate the production, maybe even get a database snapshot to replicate the same data, try to reproduce a bug, and shut down everything after a few hours, and it will cost $2. It's really because you are really only paying for what you are actually using. In traditional development, when you deliver software, okay, you probably do some Maven release and so on, and some automating things. But the last step to get this piece of software to production is mostly about explaining in the Word document the scripts to apply for this to be deployed in production. When you use the cloud, deploying an application is about calling an API. So everybody is using the same API, you just don't use the same credentials. The development process used to be fire and forget. You have tagged the 1.0 release. Even the development team starts to switch to other projects. But surprisingly, it's a time you need people with best knowledge on the software to be there. When you are in a cloud environment, you can start using continuous delivery. We'll talk about this a little later. And then it's really a helper to let you embrace the DevOps principle. I won't tell you that just being deploying to the cloud will make you DevOps. For sure, it's another level of maturity. But it will help because you don't have to be hurt with all those technical bits. So it's just you to change the way you consider development, the way you consider the distinction between a developer, an ops, a QA guy, and to start thinking, how can I help them? Maybe how can I start thinking as an ops and consider what, as a developer that need to fix bug, what the interesting metrics I need to have from production. Continuous delivery is between continuous integration and continuous deployment. Yeah, not really a good definition. Continuous integration is something really popular. Every time you commit something, you build your test and you have feedback on the status of your project. Continuous deployment is about doing the same, but deploying the application at the end. So if you are very strong testing, that's really, really cool. Every commit goes to production. In most cases, it's a bit optimistic. So we used to implement what we call continuous delivery. That means that you stop just before the production step. But the last step is really not something technical. It's really clicking a green button and using the exact same process you use every day for all the other steps. There is no stress switching to the last step if you are validating everything before. In most cases, you have a staging environment where you control everything is okay, but for this to happen, you have to manage your resources as code, not just the code. Typical sample is the way you manage your database. I know many people that are using MySQL Workbench to create the database schema or update tables and so on. But then it's really hard to replicate environments, to manage upgrades, and to tag version. You tag your code, but you don't tag your database. So the idea of managing resource as code is to have everything in your SCM, for sure your source code, but also application configuration, or your runtime definition, binding with your external resources, and so on, and database scripts to create or update database. When you can do this, you can really replicate an environment from a tag to diagnose an issue or start new features. For database, it's really not simple. So there is interesting tools on this topic. I heard lots of good talk about Flyware. I never tried it, but you should give it a try. There is also an interesting book on this topic. So I won't get deeper, but that's really something you should consider. And the last step, if you are starting to consider this continuous delivery principle and full automation of your deployment, is to have a zero downtime deployment, what we technically call concurrent deployment. It's really simple. Your application is running on a node on the cloud, and then you run the command line or the API to deploy your new version of Hello World. So it will bootstrap on your new node, and when the deployment is okay, the router will just switch the traffic. So from the user point of view, there is really no interruption of service, as long as you manage the state between the instance and so on. That lets you really deploy mostly every commit or every new feature without this concept of considering we are going to production with a new version. There is no interruption. This is a permanent beta in some way. Something you have to consider is when you migrate database, because there will be a time where you have two versions of the application in a small amount of time that will access the same database without the same schema in mind. Sorry. There is a few ways to address this. One of them is not to create constraint on database on the first deployment, but do it in 2 steps. Or if you really change your data model, you can do this the Twitter way. Who of you already have seen the whale on Twitter? The old guys here. Yeah. For the younger, that Twitter, when they were exponentially growing, had a scalability issue. And when you log to Twitter, you got this web page saying, sorry guys, we can't handle the traffic. So they had to re-implement everything, and now they are done. But it makes sense to say, okay, for 10 seconds, we will switch the application to a maintenance page because we are upgrading the database, and then switch back. And yes, okay, we'll have a dozen users to see this page. It's not a big deal. And the last point is to switch your mind to a model when deploying is not an event anymore. A typical sample is to use the green boot deployment principle. You really have 2 chains of your application running concurrently, and you can just use your cloud provider API or SDK to switch from the green to the blue one, and reverse. That's a good way, when you have complex deployment, to say, okay, I will prepare the blue line. I will use a specific, let's say, offline or whatever URL to access it and ensure everything is running, and then switch. And if anything goes wrong, I can switch back. But yeah, you don't anymore consider the staging then production phase. You are actually staging the next production. And the same server will actually become the new production one. Other thing you can implement with when those principles are in place is A/B testing. That means that you will have a portion of your web users that will use a new version or maybe a beta feature of your application. And you can collect business metrics. How are they using the new feature? Are they buying more or less items than before on my corporate site? That's a very interesting way to try to understand how your customers are using your web application. Do you, from a marketing point of view, you really collect interesting metrics. Another level on this topic is Canary Testing. You probably know it about Chrome. The principle is Canary were used in the coal mines because when something went wrong with gas, the canary died, so everybody went out. You do the same with your user. You have few % of them that are experimenting the new beta whatever version, and you collect metrics on what's happening. And that's far better than whatever Selenium or performance testing you can do, because you have real users that start clicking everywhere and doing crazy things. And thanks to this approach, you really can confirm that your feature is working. You can also confirm that it's useful. And the last step on this topic is we'll do a poll. Do you have any idea what this is? It's the very, very early first Palm Pilot. It's a paper-based Palm Pilot. The guy who invented the Palm Pilot just had the idea and wanted to ensure it was a good idea. So he created just a piece of paper and invented the UI, the physical UI of the Palm Pilot, and used it for 1 week just to check if it's useful, if it fits in the pocket, and so on. So probably he had big fingers, so he was thinking, I need something to use the UI, and being in the Chinese restaurant, he picked up a woodstock and invented the stylus. So in a few weeks, with a fake application, you can understand how useful it can be. I have no proof of it, but I heard that Amazon is using this principle. You have a small amount of users that get a new widget to appear on the Amazon website, and it's just an image. Get a new offer for 10 cents, blah, blah, blah. So they just collect how many of them are clicking. Or maybe even how many of them are triple clicking, so really interesting in this feature. And there is nothing behind, just metrics. But probably marketing had a new idea on Monday morning. They created some mashup of the image. It's on production at noon. And on evening, they have actual business metric to say, okay, we want to launch this project because based on metrics, user wants this feature. Or maybe nobody clicked. So just don't spend time with this feature. That's another way to consider agility. So for sure, you don't need cloud to implement this. You can do it by yourself with a bunch of chefs, Puppet, scripting, and Capastrino, and whatever you want. It's really interesting. I agree with you. We are engineers. We like those challenges. But if you consider a question of how your engineering resources are used and time to market and so on, using the cloud, consuming service, and adopting this new principle of deployment to just tell, okay, I'm not managing your infrastructure, I'm managing my business code. I want it to evolve, to be maintainable, to be nice design, and then you can really get quicker. So thank you very much for your attention. Just some advertisement about CloudBees, so I can pay my hotel bill. On CloudBees, you can have for free 5 applications deployed and a few hundred minutes on Jenkins to build every month. And so I encourage you to test it or whatever cloud provider you want. But really adopt the cloud. You have seen in this talk that it's not magic. But as long as you understand the constraint and embrace new architecture patterns, you really can be very efficient on this topic. And I will be there today and also tomorrow, so pick me up on the exhibition floor if you want to discuss or have a beer together. We have a few minutes for questions if you want. Yeah?
About the show downtime, are there any papers on database migration? Because we already use LeakyBase, for example, but still a migration can take a long time. If you add indexes or new applications.
Yeah. Okay, the question is about database migration and downtime. I really think the simplest way is to have a maintenance page, even if it takes time. Considering a way for new version of the application to rely on a database that hasn't been updated yet, and anyway that creates logs, on a SQL database is really complex. If you are using NoSQL, there are still some constraints, but it's far easier. So that's also a reason NoSQL helps on this topic. You can really have your data model to evolve quickly without those migration constraints. Yeah, if you have a huge database and want to create a new index, you know that for maybe a dozen minutes, your database will be mostly down. So just plan your deployment at midnight with a maintenance page for the few people that can sleep at this time, and you're done. Any other question? Yeah.
Considering distributed microservices for your application, can you assure that your instances are isolated from the web and you're not using any security for discussion between your microservices?
So the question is about microservice architecture and security, so that you ensure that every microservice only communicate with each other on some secure channel and are not exposed to everybody. On a cloud, by nature, everybody is exposed. If you are using typically Amazon VPC or things like that, you already are in a secured context, so that's an option. If you are considered the microservice principle, the idea is that you start splitting your application into very domain-focused services, and quickly you will discover that some of them can be useful for other applications. So it's not just black and white about security. The simplest way to address this is to use authentication tokens that are used on REST services. That's far enough so to avoid such issues. Other question, maybe? Okay, thank you very much.